Hello everyone, welcome to SM Tech Call. Today we are going to solve another LeetCode problem named swapping nodes in a linked list. So basically, if you have not read the problem statement, you can pause the video right now, then we can begin. So what they are saying here that we will be given one linked list and we will be also given another integer called k. Okay, so now we need to iterate through the given linked list and we need to pick that kth node from the beginning and we also pick the kth node from the end. Okay, and then we need to swap those two nodes. Okay, so I think discussion is pretty straightforward. Let's try to see the given example once. Okay, so what they are saying here, suppose this is our linked list and our k value is equals to 2, so that means we need to identify the second node from the beginning. Okay, since the k is 2, this is the second node, and we also need to identify the second last node. Okay, so this will be our second last node from the end, right? So basically we need to swap these 2 and 4 node and then we need to return the head. Okay, so in the second picture you can see that we already swapped this. We swap 2 with 4. After swapping it will look like this: 1 4 3 2 5. So this is the thing that we need to solve. Okay, so I think hope you understand this problem. Now let's try to identify some solution for the same. So in this video we are going to see couple of approach to solve the same. So at first we will see one basic approach. In that approach we will use some extra memory and using that we will solve it. Okay, so how we can solve it? So probably what we can do, we can take one array and then what we will do, we will iterate through this linked list, given linked list, and we will insert those value into the array like this, right? 1 2 3 4 and 5, correct? So now we can easily, since we know that in the array we can easily fetch any value using index in order of one time, right? So we will convert this linked list to array. Then suppose I will fetch the second element, right? So it will be k minus 1 element, so that is I can see 2 here, right? I can easily find out that from the array, and similarly I can find out the second last element using index, right? So I can easily identify these two nodes, then we can easily swap this, right, inside the array only, right? So it will look like this: 1 4 3 then 2 then 5. Now easily we can iterate through the array and we can create another new linked list and we can return the head. So at first let's see the code of this approach, then we will try to modify this. Okay, so how we can solve this? So probably we will use array list here, since if we want to use array then we need to know the exact length, right? That is not known to us because linked list can be any size can be anything, right? But in the Java, if you want to declare any array, then you need to provide the size. So since we don't know about the size, so probably we are going to use array list here. So let's take one array list and we are going to store integer number only here. So the type should be integer and let us name it as list only, and let us quickly initialize it as array list. Okay, now what next? We declare one array. This array is already declared. Now we are going to iterate through the linked list and we are going to add all the values into the array list. Okay, so to do that we can use while loop, and since we need to return the head later, so probably we are going to take another variable. So let us name it as current, something like this, and we are going to store the reference of head, right? Why? Because suppose whenever in the while loop we will keep changing our head to the next position, right? So whenever we are done with our first iteration or linked list traversal, our head will point to null. So that we need to store that head reference in a other variable, that is current. Okay, now we will run one while loop and this will run till my head is not equals to null. Okay, now suppose I am here in the first position, right? In first position or first node, I am going to just insert that value in our array list. Okay, so it should be list dot add and we are going to insert head dot. After that we need to move forward our pointer to the next position, so it should be head dot next, head equal to head dot next. Okay, so after this while loop our array will look like this, or array list will look like this, right? Every value will be inside our array list. Now what next? Now I need to swap those two value, right? So I need to find out this second value and the fourth value and then we need to swap it. Okay, so let's do that. Let's take one variable called temp, and since it's an array list we can use get method, so it should be list dot get and we need to get the second value, right? So since indexing starts from 0, we will write like this. It should be k minus 1. So this will give us 2, okay, the value 2 in the temp variable, right? And we are going to take another variable, probably let us name it as temp2, and in this variable we are going to store our second last value, right? So it should be my my list dot size minus k, okay. Now easily we can swap it, right? So let's quickly swap it. Okay, so let's do swapping now. So now I will update. So array list comes with one inbuilt method called set. Basically in the set method we need to pass two things: the index where I need to update and the new value, right? So at first we will swap. So this temp2 variable contains value 4. So at first let's set 4 in the second position, right? So we will write like this: k minus 1, that will be my index, and our new value will be temp2, okay. And similarly we will update the fourth position value, right? So here my index will be list dot size, and it should be minus k, and our value will be temp, correct? So after this our array list will look like this, right? 1 4 3 2 5, correct? Now we need to build another linked list from this array list only, right? So let's do that. So we will again take another for loop probably, and we need to pick each and every number from this array list, okay. So let us name it as int num, and we are running as for loop here. Now what I will do, so my head will be initially null, right? So I need to check that if my head is equals to null, that means this is our first node, right? Suppose I am here, and now I want to create one linked list with 1. So if I see it is head, then we need to use some other logic, and for other nodes we are going to write this one in the else node, okay, or sorry, in else box, in else block, okay. So if I see my head is equals to null, then we are going to initialize the head as head equals to new linked list. And since you can see this constructor, right? So we have 3 constructors. We can, but one is the no argument constructor, one with value, and one is value and node. So okay, we are going to use the second one, and we are going to just pass the value, right? So num is our value, right? And else we are going to, so if I see it is not the first node, then we can easily update the next node, right? So our head dot next should be equals to new list node, okay. So sorry, this should be list node only, since our class name is list node, so it should be list node. Similarly here we are going to initialize with num only, okay. Now we need to move to the next pointer, right? So now my head, suppose I picked 1, and now suppose I came here, I need to add it in the next pointer, right? So it will point to 2. After adding 2, again we need to add 3, right? So we will move that to our next pointer. So head will be equals to head dot next, okay. And once we are done, we need to return the current, right? So return current. But before that, current was containing the older head, right? So once we update our new head, we are going to update our current variable also, right? So it should be current equals to head, okay. So let's quickly run the code and see whether it's running for the first test case or not. Okay, you can see it's giving us expected answer for the first test cases. Let's quickly submit this. Okay, you can see our solution is accepted. So let's check the runtime also. Okay, so what will be the time complexity of this solution, right? So at first we are running this while loop, right? It will take order of n, where n is the linked list size. Then we are just performing some update operation, basically just swapping operation. Then again we are running another for loop, that is also size of n, list size, right? List size is nothing but the array list size is nothing but the actual linked list size, okay. So overall time complexity of this solution is order of n. And what about the space complexity? Yes, we are using extra spaces here, that is we are using one extra array list, and that size can be up to n, order of n only, right? So in this case our time and space complexity both are order of n, okay, of this solution. Let's try to optimize the same. Let's try to solve the same problem without using any extra spaces. So our time complexity will be remain same for the new solution, but we are not going to use any extra list or something like that, okay, or any extra space, okay. So how we can solve it without using extra spaces? So basically what we will do, at first our first task will be identify the length of the linked list, okay. So we will run one while loop and we will identify the length. So in this case I can see length is 0, 1, 2, 3, 4. Okay, so if we start from 0, our length is 4. Now what next? Now again I need to identify these two nodes, right? This first node and this second last node. Okay, so again I will run while loop and I will identify these two nodes, and probably I am going to store the same in two different variables, probably the first node and the second node, that is 4, right? And so once we identify these two nodes, then easily we can swap the value, right? So by this approach we are not going to use any extra memory. Okay, so let's quickly see the code that will surely give you much better understanding. So for this approach we don't need any extra variable, but we need couple of we don't need any extra spaces, but we need couple of variable, right? The first one is the list node, and let us name it as first. That will contain the reference of our first node, and we need another list node that will be second, and again let's initialize it as null only. And apart from this we need another temporary or current node that will store the reference of our head. And apart from this I think we need another variable called length that will store the length. Okay, it should be length should be initially 0. Okay, now what next? Now we need to iterate through this linked list and we need to identify the length. Okay, so again we are going to run another while loop here, and we will run till my head is not equals to null, right? So okay, fine. Now I will check that if my, so while iterating for the first node, right, or first time, right, we can easily identify this first node, right? So we will check that if I see my length is equals to k minus 1, since we are starting from 0, then we are going to update our first variable, right? So it should be head. Okay, so using this if condition we can easily identify the first node. Okay, now we are going to increment our length, since we need to know the actual length, right? So if we are not able to understand the actual length, then we will not be able to identify this second last node, right? For that reason we are identifying the length. Okay, and head should be equals to head dot next. Fine. So after this while loop I will be aware that what is my length of our linked list. Okay, now again I need to run the while loop and we need to identify the kth node from the end, right? So let's reset our head to the starting position. So head should be again equals to current, because again I need to start from the, because after this first while loop it will be null, right? Head will be null. So again we need to start from the first, so that we are writing like this, head equals to current. Now again I will run while loop and I will check, and probably we need another temporary counter. Let's name it as count, so that we can identify the last kth node from the last, right? So it will, this time while loop will run till my count is not equals to length minus k. Okay, so I will run until I found this fourth node, right, in this example. And similarly I will keep updating our count after each iteration, and we will move our head also, right? So head should be equals to head dot next. So whenever I will see that I reach this second last node, it will come outside the while loop and we are going to update our second variable, right? Let's quickly do that. So second should be my head. Now we can easily swap this value, right, between first and second. So let's do that. Let's write a simple swapping logic, right? So temp will contain the first dot val, and let's update our first dot val with the second value. So it should be first dot val equals to second dot val. Okay, and now we are going to update the second dot val using the temp. So basically this is a basic swapping logic, right? And once we are done, we are going to return our head, right, that is the current. Okay, I think that's pretty much. Let's quickly run the code and see whether it is running properly or not. Okay, you can see it is giving us expected answer. Let's quickly submit the same. Okay, I think this solution is also accepted. Now let's check the time and space complexity here. So here we can see that we are not using any, sorry, this was our solution, right? So here we can see that we are not using any extra spaces, but we are using some extra variable, 4 to 5 variable, but in this case our space complexity will be order of 1. Since this we are going to use this much these 4 variables only for any size of the given linked list. Okay, so that in this case our time complexity is order of n, but space complexity is order of 1. Okay, I think that's pretty much for this video. If you like this video, please do subscribe to our channel, and if you still have some doubt, you can ask me in the comment section. Thanks for watching. Bye bye.